In this video, we will discuss the gauge pressure, vapor pressure, and cavitation phenomena. So let's focus on the gauge pressure. So when the absolute pressure measure from the atmospheric pressure is known as gauge pressure. So what is gauge pressure? Suppose this is here, this is the zero pressure. Suppose this is the zero pressure, okay, and here there is a atmospheric pressure PATM, that is the atmospheric pressure. So when the gauge pressure, when the pressure is above atmospheric pressure, this is known as positive gauge pressure, okay, and if the pressure is below the atmospheric pressure, that is known as vacuum pressure or negative gauge pressure, okay. So what is the relation between absolute pressure, atmospheric pressure, and gauge pressure? So we know that absolute pressure, that is equal to atmospheric pressure, ATM pressure, plus gauge pressure, okay. So this is the relation. Remember this relation, important relation. So absolute pressure, okay, so here P is the absolute pressure, P is the absolute pressure, PATM, that is the atmospheric pressure, and P gauge is the gauge pressure, okay. So let's write the definition of gauge pressure. So when the pressure is above the atmospheric pressure, that is the positive gauge pressure, and below the atmospheric pressure, that is known as negative gauge pressure, or you can say that is the vacuum pressure. So we know that atmospheric pressure, that is 101.325 kilopascal, and this is the zero pressure, means pressure here, this is the zero pressure line, okay. So this is the positive gauge pressure, this is the positive, so this is the positive gauge pressure, okay, and this is the negative gauge pressure, or it is also known as vacuum pressure, okay. So let's write the definition of the gauge pressure. So when the absolute pressure measured from the atmospheric pressure is known as gauge pressure. So when the absolute pressure measure from the atmospheric pressure, atmospheric pressure is known as gauge pressure. So if the absolute pressure is more than local atmospheric pressure, then the gauge is known as positive gauge pressure. So if absolute pressure if absolute pressure is more than local atmospheric pressure, more than local atmospheric pressure, then the gauge is known as positive gauge pressure. Then the gauge is known as positive gauge pressure. Okay, and if the absolute pressure is less than atmospheric pressure, then the gauge is known as negative gauge pressure. If the absolute pressure is less than atmospheric pressure, then the gauge pressure then the gauge pressure is known as negative gauge pressure. Then the gauge pressure is known as negative gauge pressure. Negative gauge pressure. Okay, or it is also known as vacuum pressure. So it is also known as vacuum pressure. So there may be positive gauge pressure, there may be negative gauge pressure, but there cannot be negative absolute pressure. So gauge pressure are defined by local environmental pressure. So gauge are calibrated as per their local environment. So let's write this. So there may be positive gauge pressure, there may be negative gauge pressure, but there cannot be negative absolute pressure. There is no concept of negative absolute pressure. Absolute pressure. So gauge pressure are defined by, so gauge pressure are defined by local environmental pressure. Local environmental pressure. So the gauges are calibrated as per their local environment. So their local environment. Okay, so this is all about the gauge pressure. Now we'll understand the vapor pressure. So the next topic, that is the vapor pressure. So vapor pressure. vapor pressure. So what is vapor pressure? So it is the saturation pressure exerted by a liquid vapor on the liquid surface at a given temperature. So this is very important. So each liquid have its own vapor at given temperature. If the absolute pressure of the liquid becomes less than the vapor pressure of the liquid at a given temperature, the liquid boils or evaporate. Okay, so the main definition is that if the saturation pressure exerted by the liquid vapor on the liquid surface at a given temperature, so it is the saturation pressure exerted by the liquid vapor on the liquid surface at a given temperature. So in that pressure the phase change happen, that means the liquid converted to vapor. Okay, so let's write the definition. So it is the saturation pressure exerted by the liquid vapor on the liquid surface at a given temperature. So each liquid have its own vapor at a given temperature. So each liquid have its own vapor at given temperature. Own vapor pressure at a given temperature. So if the absolute pressure of the liquid becomes less than vapor pressure, if the absolute pressure of liquid, if the absolute pressure of the liquid becomes less than vapor pressure, vapor pressure of the liquid so at the given temperature the liquid boils or evaporate. Okay, so this is all about the definition of the vapor pressure. Okay, so now let's try to understand another concept, that is cavitation. Okay, so let's try to focus on the cavitation. So next topic that is cavitation. So if the fluid flow, if the absolute pressure of the liquid becomes less the vapor pressure of the liquid at a given temperature, then the vapor bubbles are formed, and if this bubble carry in the region of high pressure, the bubble gets collapsed and it may erode the surface is known as pitting or cavitation phenomena. Okay, so so suppose at a given temperature there is a vapor pressure, and if the absolute pressure of the liquid becomes less than the vapor pressure, then when the liquid goes to the higher pressure region, the this bubble, due to bubble collapsed, it may erode the surface. Okay, so this is known as the cavitation phenomena. Okay, so here suppose this is one system, sorry, so consider this is one system and there is a liquid inside that system. So this is liquid inside the system. Okay, so there is a liquid inside that system. So at a given temperature, so at the given temperature. Now if this here the pressure, if the pressure is less than the vapor pressure, then what happen? So there is another piston cylinder arrangement or another system. There is another system, and consider the displacement of the piston like in the upward direction. Suppose there is a displacement are there. This is the displacement of the piston. So due to this displacement of the piston, the here there is a liquid level, and after that there is a vapor pressure is created. So here the vapor pressure created. So this is the PV is the vapor pressure. So due to this vapor pressure, the liquid which is converted to vapor. So here the liquid converted to vapor. So here in that case, that is evaporation happen. Okay, so it is happen in the at the suction side of the centrifugal pump. It is happen. So here what is happen? So liquid is converted to vapor. So here liquid converted to vapor. So at saturation state, so it is at saturation state or equilibrium condition. So at saturated state or equilibrium condition. Okay, so it is happen at the suction side of the centrifugal pump, exit of the reaction turbine and siphons. So the application is that, so the application, where is the application? So at the suction side of centrifugal pump, at the suction side of centrifugal pump, exit of reaction turbine or siphon, etc. Okay, so let's write the definition of the cavitation. So what is the definition? That is the in fluid flow, if the absolute pressure absolute pressure of the liquid the absolute pressure of the liquid becomes less than vapor pressure okay, less than vapor pressure of the liquid at the given temperature at the given temperature then the vapor bubble are formed and if this bubble carries in a region of high pressure, carries in the region of high pressure, the bubble gets collapsed and it may erode the surface known as pitting or cavitation phenomena. So known as pitting, 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 or it is known as cavitation phenomena, pitting or cavitation phenomena. This is known as pitting or cavitation phenomena. So this is all about the cavitation. Now if we see the TH diagram, so this is the TH diagram here. So here this is the temperature, entropy, T is the temperature, S is the entropy. So there will be the vapor dome. So this is the vapor dome here, and this is the liquid here. In that zone there is a liquid plus vapor. So this is here the liquid plus vapor region, and this is the vapor region. Okay, so so here suppose at a given so this is vapor pressure line, so this is pressure line at this is the pressure line, okay, in the saturated zone. Okay, so this is the saturated condition. So here this zone is known as saturated condition or saturated zone, saturated condition. So liquid vapor means there is a saturated condition. Okay, so this is the constant pressure line, and with respect to this the temperature is considered, this is T1. So this is another pressure line, this is another pressure line, and this is another pressure line. So with respect to that, consider the temperature is there. Okay, so as the vapor pressure, as the pressure increases, the temperature is also increases. So as the temperature is increases when the vapor pressure is increases. So this is important, and try to remember this data. At 20 degrees Celsius temperature, what is the vapor pressure of water? So at 20 degrees Celsius temperature, 20 degree Celsius temperature. So vapor pressure of water, that is 2.5 kilopascal. Remember this data. At 100 degree Celsius temperature, the vapor pressure of water, that is 100 kilopascal. Oh, that is almost 1 atm pressure. Okay. At 20 degree Celsius temperature, the vapor pressure of gasoline, that is 30 kilopascal. At 20 degree Celsius temperature, the vapor pressure of mercury, that is 0.17 kilopascal. So here we see that the vapor pressure of mercury, that is very less as compared to other fluid. So that's why as the vapor pressure is very less, so to measure the atmospheric pressure, we use the mercury in the barometer or in thermometer. So that's why as the vapor pressure is less as the vapor pressure is less for mercury, so we use this fluid in our to measure the atmospheric pressure in barometer. Okay, so remember this data, important data. Okay, so now let's try to understand one converging diverging channel. So there is one converging diverging. So this is one converging diverging zone. So here there is a water, consider this is water coming in, that is flow rate Q, and water going out. So water going out. Okay, so this is water here. So here we see that the area gradually decreases and then the area gradually increases. So we know that Q, that is flow rate Q, that is equal to area into velocity. Okay, so as area decreases, so area decreases means the velocity will increase. So here in this zone, the area is the minimum, so velocity will be what? Velocity will be maximum. Okay, so from this relation, and here Q equal to A into V, we know that. So as here the area that is increases, so area is increases, so velocity will be decrease. Okay, so here the velocity increases, okay, and here the velocity is maximum, and then velocity decreases with respect to this length. Okay, now if you measure the pressure, so here the pressure will be minimum. Why this pressure will be minimum? So if we write the Bernoulli equation for any two point, so we know that P1 by omega plus V1 square by 2g plus z, that is equal to P2 by omega plus V2 square by 2g plus z2. So z is the reference line. So z is the reference. This is the reference line. So here consider this is point 1 and this is point 2. Okay, so the distance from point 1 to point this reference line, so this is z1, and this point to this point, the distance is z2. So z1 equal to z2, so this is cancel out. So we see that here the velocity increases. Okay, the velocity will increases. So velocity increases means what happen? If the velocity increases, there must be condition that the pressure will decrease. Okay, so due to that, here this point the pressure will be minimum, because the velocity is maximum. That's why here the pressure will be minimum. So this side, this point pressure will be minimum. Okay, and in that region, so as the velocity is decreases, so if Suppose uh, for so this is so here uh, suppose this is the point, another point. Okay, if the velocity decreases, if the velocity decreases, so here the velocity is decreases, so here the velocity is decreases, so what happen, so pressure will increase, so at that point the pressure will increase. Okay, with respect to this, so here the pressure is minimum and then the pressure is increase, so here pressure P1, then pressure gradually decreasing and then pressure increases. So this is all about the cavitation phenomena. Okay, so this is my handwritten notes, you can download it from the description. If you have any doubt, you can directly comment me. There is a WhatsApp group and Telegram group. You can join this group for a regular update. Like, share, subscribe my YouTube channel. Thank you.